Riley, and Reese. This is 6-3. We're spending another day on parallelograms, and then we're moving on. On Monday, we'll start rectangles and squares and all the easy stuff, okay? You will have a mid-chapter quiz tomorrow after section 3, so make sure you have all your notes ready to go. You can use those on the quiz, and then you won't have homework over the 4-day weekend or whatever it is, right? So, tests for parallelograms. Yesterday we spent time on parallelograms. We were talking about what makes a parallelogram, like what qualities he has, right? So, like the obvious ones, the opposite sides are parallel, the opposite sides are the same length. What was this thing where we had, like, what was it about that? What was that all about? Yeah, the ones that are right next to each other. So any ones in those loops are going to add up to be 180. That's the thing. And then we talked about the diagonals. Okay, so what's true about those guys? They're not the same length, but they bisect each other. So like this piece will be the same as this one. Same thing with this one will be the same as that one, right? So like they cross at the midpoint, basically, okay? Today, rather than like yesterday, they said, this is a parallelogram, find me some things. Now they're going to give you some shapes, and they're going to say, okay, here's some information. Is that thing truly a parallelogram? Here's some more information. Is that truly a parallelogram, or could it like be a little skewed to one side or something, you know, like does that work, right? So here we're trying to test to see if they give me this information, will it be a parallelogram? So here we go. In section 6.9 or theorem 6.9, we're not going to write these down on a blue sheet or a purple sheet or whatever it is. Theorem 6.9 says that if the opposite sides are the same length, so opposite sides are congruent, they don't have to tell me that they are also parallel. They have to be parallel. Like there's no other way around it. If they tell me that the opposite sides are congruent, I know I'm looking at a parallelogram. Like that's the way that 6.9 works. Okay, don't have to tell me that they're parallel. All right, the next one says that if the opposite angles, both sets of opposite angles, if the opposite angles are congruent, then I know I'm looking at a parallelogram. They don't even have to tell me any information about the sides. They don't have to tell me that they're congruent. They don't have to tell me that they're parallel. I know I'm looking at a parallelogram if the opposite angles are congruent. Got it? This one right here says, okay, let's say that they don't give us any information about the sides or the angles, but they tell me that the diagonals split each other in half, or the diagonals bisect. If I know that the diagonals bisect each other, like this is the same as this and this is the same as this, they don't have to tell me any more information. I know that I'm looking at a parallelogram. Got it? So if they just give me that, I know that he's a parallelogram. Okay? And then this is the last one, which is one that we have not talked about before. Okay? You ready for this? This one says that if we just look at one set, like we don't know anything about this side and anything about this side. If they give me one set that is the same length, and I know that they're parallel to each other, then they don't have to tell me any information about these two sides. I know that that has to be a parallelogram. Okay? Now, Ellie asked me this question. She said, okay, what if they just say that one set is parallel but not the same length? Like, let's just say that they say that this guy is parallel to this guy. Don't these two have to be parallel? And I said, okay, I'm going to draw you a picture of that. Here, this guy is parallel to this guy, right? And they're not the same length, right? Does that make a parallelogram?
Yeah.
No, that's trapezoid.
Yeah.
Okay? Even if they say, hey, these two are the same length, right? And these two are parallel. Does that make it a parallelogram? No. It would have to be that this guy's parallel to this guy and this one's the same length as this one. So if I then make this one longer so these the same length, does that make a parallelogram? Mm-hmm. Yes, right? So this same side has to be parallel and congruent in order for it to make a parallelogram. I can't mix and match. Does that make sense?
Do you have to use the whole of like the whole line?
What do you mean? Come, here you go. Come show what you're talking about.
I don't know if this would work or not, but
Sure.
you have to
Try it.
use
Let's
the
see.
whole thing where you could just go like that. Couldn't you just do one like that or something? Because then these two would both be parallel. But you wouldn't be using this whole one.
Yes, true. So it could be the case, but
You have to use the whole line?
no, like
cause say you're only using part of that
If that
line.
happened, then this would be the same length as that one, right?
Oh,
So
okay.
so basically, the way that this goes, so yeah, I get what you're saying. Like, could it be that way? It could work, but it doesn't in all cases.
Okay.
So what we're trying to prove is like, does that make a parallelogram in every circumstance? Does that make
Okay.
sense?
Yeah.
And if it doesn't, if we could draw a picture where it's not a parallelogram, then it's already false. Does that make sense?
Okay, yeah.
Like, they're saying in all cases, if I give you this information, would it make a parallelogram?
Okay.
It might make a parallelogram, but if we could draw it without, then it's not going to work. Okay? All right, so let's do this one right here. Here we go. They give me that this is 14 and this is 14. So I have this side is congruent to this side, right?
Yeah.
Okay? I need a little bit more information from that. So I either need to know that this side is the same as this side. Do I know that?
No.
No, not necessarily. Or I can go off of this thing right here that says that if they're congruent and parallel to each other, come on, if they're congruent and parallel, then we're good to go, right? So I know that 14 and 14, these are congruent to each other. Do I know that those lines are parallel?
No, they could be offset.
Billy says yes. Billy says those two lines have to be parallel.
180.
Yeah.
This line right here and this line right here, this angle and this angle, the fact that they add up to be 180, does that mean that those two lines have to be parallel to each
Yeah.
other? Yeah, because these are consecutive interior. Remember when we did alternate interior, corresponding consecutive interior, those guys? These add up to be 180, which means that even though it's not marked, we can conclude that this is parallel to that one. So now I have that this side is congruent and parallel to the bottom side. So this is, yes, a parallelogram by which theorem up above? 612. We're going to put that in there. So yes, by theorem 612, we know that that's parallel and congruent. It wasn't marked, but from the information given, we can conclude that, right? Okay? All right, the middle one's the easiest one. Is that a parallelogram?
Yes.
I have this is the same as this, and this is the same as that. This is,
690.
yes, a parallelogram because of 6, 9. That's the very first one we did, right? The opposite one's the same. Got it? This one over here, I know that this side is the same as this one. So if we can conclude that this guy is parallel to that one, we're good to go. But they give me 85 here, and they give me 85 here. And if they do that, does that mean these two are parallel?
No.
I don't think so. I don't think that's going to work because those are opposite corners. And we don't have like one transversal that we're looking at. Okay? So this one's going to be a no. There's not enough information. It might be a parallelogram, like Josie said. It might. It looks like it is. But there's, you know, like a chance that it maybe isn't. Does that make sense?
Yeah.
Right. Okay. All right. Good. Let's go down to the next one. This is the tackle box example that I was talking about. So they tell me in the paragraph, I'm going to circle this part, PQ is equal to RS, so that's this top one right here. PQ and RS, those guys are the same, and then PR is the same as QS. So I have this little shape going on right here, okay? They are asking me, do I know for certain that this guy will remain parallel to this guy as he is raised and lowered? Will those things stay flat with each other?
Yeah.
Why?
Is that hinge theorem
Because this guy is a what?
parallel?
He's a parallelogram. He's a parallelogram. And that means that this top side will always be parallel to that bottom side, right? How do I know that this thing is a parallelogram?
Both sides 6, 9.
6, 9, right? All of the sides, the opposite sides are the same. So by theorem 6, 9, I know that's a parallelogram, which means those sides will continually be parallel to each other as I raise and lower them, right? Okay? So, like, that's by design. Like, they use geometry to, like, do this stuff because it works, right? That's how tackle boxes are designed. Okay? Backside, here we go. They have a lot of stuff in this paragraph up here, and none of it's labeled down here. This is not a hard problem, but we got to label. So F, from F to K, the F part to the middle part is 3x minus 1. So like this little distance right here is 3x minus 1. I'm going to label him on the diagram. Then they tell me that KG, which is this right here, is 4y plus 3 plus 3. Then they tell me that YK, this guy right here, is 6y minus 2. And then they tell me the last one is KH is 2x plus 3. And I'm trying to find x and y. That's all I'm trying to find.
Just set them equal to.
Set the opposite ones equal. So these two are going to be the same as each other. Let's set them equal. 3x minus 1 equals 2x plus 3.
X equals.
And we can subtract the 2x to get them over here. And I can add the 1 to get them to the other side. So 3x minus 2x is x equals 4. You're right. Then let's do the same thing for the other one. So this equals this. 6y minus 2 equals 4x, or 4y, not x, plus 3. Okay, let's subtract the 4y. And let's add the 2. And this doesn't come out nice, but it's fine. 2y equals 5 and y equals
2.5.
2.5 if we divide. 5 divided by 2, 2.5. Okay, just solve for x and y. You may come out with decimals on this, and that's okay. Like, you're not doing it wrong, right? Okay, we're gonna come back to this box after we do example 4. We're not gonna do example 5. We're gonna skip the proof. And example 4, here's what it says. Let's plot these points right here. 2, 3. 2, 3 is K. And we've got L is 8, 4. 8, 4, we're off the chart a little bit. 7, negative 2. 7, negative 2 is M. And then N is 1, negative 3. I gotta talk to myself, sorry. N. Alright. There we go. That shape. It looks like he might be a parallelogram. I don't know for sure.
Well, he's got the same
I think he is.
rise and run.
That's what we're gonna do. That's what we're gonna check now. Determine whether the quadrilateral is a parallelogram. Justify your answer using the slope formula. All right, we're gonna do this. I'm gonna add to this. Sorry. We're gonna look at the slopes, and then we're also gonna look at the distances, because I think on your homework assignment they might have you do distances as well. So I'm gonna add to this. We're gonna do an extra step. We're gonna do the slopes and we're gonna do the distances. Okay. We need to find the slopes of all of them. This is gonna be kind of a pain in the butt. KL is one side, LM is another side, MN is another side, and KN is the last side. So we're gonna look at the slopes of each one of those. Okay? Now, you can do this without having to graph. If I'm looking at the slope from K to L, I'm looking at these two right here, and I could just do y2 minus y1 over x2 minus x1. I do not have to graph them, right? But because I have the graph, I'm just going to use it to my advantage, and I'm just going to do rise over run of this guy, right? How much is he rising from here to here?
Up 1.
Up 1 over?
1, 2, 3, 4, 5, 6.
Up 1 over 6. So his slope is 1 over 6. All right, now, I want which other side to also be 1 over 6? MN, right? Is MN 1 over 6 also?
Yep.
So that means that those guys are parallel. Okay, now I just need to do these two and see if they are parallel also. And if they are, that means this is a parallelogram, and we have like proved it, right? So from L to M, like these two guys, how much is it rising, how much is it running?
1.
6 to 1.
Yeah, I think it's going up 6 over 1. Is the other one also up 6 over 1? Okay, now again, we could have done that with just the coordinate points and done like y2, y1, x2, x1 and looked at those. But now we have it confirmed. Yes, this is a parallelogram. Yes, it's a parallelogram. Okay, now let's say instead they say, I don't want you to use slopes. I want you to use distances instead. Okay, so let's do the distances. KL, LM, NM, and KN. We got to do the distances of these. Do you know how to do distances? Do you remember how to do that? Distance formula, that's the square rooty thing. Square root, square root, square root, square root. And we got plus, 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 and we got a square. Square, 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 square. Okay? Again, you can do this without actually like having the thing graphed. We're gonna find the distances of each side. So K to L
Would it be 6
is going
squared or
from
10
2
squared?
to 8. How far apart are 2 and 8?
6.
6. So it's 6 squared. Okay, how far apart are 3 and 4?
1.
1. Okay, 6 squared plus 1 squared is the square root of 37. Got it?
Yep.
Okay, I want the bottom one to also be the square root of 37, so I'm gonna skip down to that one. Let's go from from 1 to 7
6.
is 6, and from -3 to -2 is 1. Is that the square root of 37? You betcha. So those are the same length. All right, now, so they're not parallel, they are congruent. Now I want to prove that the other two are congruent. Okay, let's see if they are. LM is this guy right here. So from 8 to 7 is 1, and 4 to -2 is 6. So I have 1 squared, 6 squared. That is
7.
the square root of 37 again. What the heck? And from K to N, from 1 to 2 is
37.
1. 3 to -3 is 6. So I've got another square root of 37. So the fact that these two are congruent and these two are congruent means the opposite ones are congruent, which means yes, this is a parallelogram, but I did it not by doing the slopes and saying that they're parallel, but by doing the sides. So yes, this is a parallelogram. Does that make sense?
Mhm.
Now, this is a better parallelogram. He has actually a more special name than parallelogram. Do you know what he is? He looks like he's a square because all of them are the same length, but he's not a square, he's a tilted square. And a tilted square is called a rhombus. A rhombus. We're going to learn a rhombus here in a little bit. Okay? Like on Wednesday or Tuesday or Wednesday of next week, we'll go over rhombus. Okay? But a rhombus is a tilted square.
Formula again?
Slope
Y1
formula?
plus Y2 is.
Y2 minus Y1, X2 minus X1.
Hang on, okay, say that again.
Y2 minus Y1 over X2 minus X1. That's the slope. So if you want to do that without having to graph, you just do the coordinates. Y2, Y1, X2, X1. Okay? All right? Let's go back up to the box real quick and then we'll talk through those. Okay? All right. This first bullet point says that I can prove that a quadrilateral is a parallelogram by using the coordinates if I show that both pairs of opposite sides, whoa, I don't know what just happened. Woo. Both pairs of opposite sides are parallel. How do I show that opposite sides are parallel?
The dash, or the triangles.
How do I show that sides are parallel to each other? What's that gonna involve? Right, I did it down here. How did I show that these sides were parallel?
Slope.
I looked at the slopes, so I'm gonna do slope formula for those. Okay, now instead of doing that, I could instead do that opposite sides are congruent. So how do I show that the opposite sides are congruent or the same length?
Distance.
I'm doing distance formula. Okay, so I could do like 4 distance formulas to see if the opposite ones are congruent. All right, now show that both pairs of opposite angles are congruent. Okay, this one's a little bit harder, like we don't have a way of figuring out the measurement of the angles, so we're not going to do that one. But like if I could do that, if I could do the angles, I could see that those are congruent. Okay, and then the next one, show that the diagonals bisect each other. Okay, so let's talk about that real quick. For a parallelogram, we know that the diagonals bisect. How can I prove that the diagonals are bisecting?
Point through them.
Yeah, I just do the midpoint, right? And I can do the midpoint and show that, hey, the midpoints match up and the diagonals are bisecting each other. So that's a midpoint formula. Okay? And then the last one is show that a pair, so not both sets, but a pair of opposite sides are parallel and congruent. So I only need to do 2 sides, but I do the slope of those and I do the distance of those, right?
Slope.
So I'm still only checking 4 things, right? But I'm doing 2 slopes and 2 distances rather than doing 4 slopes or 4 distances, right? Like up here I'm doing slope formula times 4. Here I'm doing distance formula times 4. And that bottom one I'm taking just the 2 sides that are opposite and I'm doing the slope twice and the distance twice. Does that make sense?
Yeah.
Okay. So that's like the you know one set, picking on one set, okay? Those are ways that I can show that he's parallel if I'm given coordinates. Got it? Okay, on your homework assignment.
What was the midpoint theorem though? Or
Midpoint
formula?
midpoint is finding the average. Okay, so write it down right here. Midpoint formula, if you need that, is you're adding the x's together. X1 plus x2 and divide by 2, and y1 plus y2 divided by 2. So midpoint formula, find the average. Adding the x's, adding the y's.
Times
Got it?
x2 or plus x?
Plus. That should be a plus. But I got my thing kind of tilted, so it's like, that's midpoint formula. Okay? Good, good?
Great.
Alright. All on skills practice, but you can skip number 6 and 7. I'll make you do number 5.
6 and 7.
6 and 7. That means you can use this whole spot to do all your work for number 5. Okay? 1 through 4 is kind of easy. Those are just yes, no questions. But if it's a yes, make sure you tell me like 6-9 or 6-10 or 6-11 or 6-12. One of those theorems. Okay? So 1 through 4 is just a yes, no. Okay? Then you're solving stuff at the bottom. Practice side, do all again. This one is yes, no on 1 through 4. But you can skip number 6. So all of them here, but skip number 6. And the rest of them are just solving things.
Can we also skip 11?
11 is not hard.
I know, but could we still skip it?
No, you can do it. It's not hard. It's not hard. Okay, happy with that? I mean, you're not happy with it, but you know, you'll make do, right? Okay, make sure you're ready for mid-chapter quiz tomorrow. Have your notes all good to go, and then no homework over the weekend. There you go. Woohoo!